Hi everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why some popular ideas about how our brains work just don't seem to go away, even when scientists say they're wrong? Well, have I got a study for you. This paper dives deep into those brain myths that we hear all the time and looks at how common they are. Not just for teachers, but for everyone. It's about how society understands the developing brain and whether we're getting it right. So, what is the big idea here? Scientists have noticed that lots of interesting brain research gets simplified or misunderstood when it goes public. This leads to what they call neuromyths, basically brain myths. These aren't just silly ideas, they're things that can actually change how we teach, how we think kids learn, and even how we understand development. The researchers wanted to see just how widespread these myths are in the everyday population in Switzerland. They figured out that even though people know more about the brain now, these myths are still sticking around. Think about it. For years, we've heard amazing things about the brain, and with new technology like brain scans, science is really digging deeper. This has led to a field called educational neuroscience, which tries to connect brain science with how we learn and teach. But here's the problem. When scientific findings get passed around, they can get twisted, misinterpreted, oversimplified, or just plain misunderstood. That is where neuromyths come in. The Organization for Economic Cooperation and Development, or OECD, defined neuromyths as misconceptions that come from misunderstanding scientific facts about the brain. They often have a tiny bit of truth to them, but they get blown way out of proportion. Now, this isn't a new problem. Researchers have been studying how common these myths are, especially among teachers. And the numbers are pretty high, often between 40% and 80% of people believing some of these things. This is a big deal because teachers are the ones shaping how kids learn. Even if they don't directly cause bad learning, these myths can lead to using teaching methods that don't really work, and distracting from what we know does work. And it is not just about schools. Many neuromyths are about fundamental things like how the brain develops, how we learn, and even mental health. This means these myths can affect how the public understands child development, learning, and even mental health care. For example, if we have wrong ideas about when certain skills should develop, we might misinterpret normal differences in kids as problems, leading to the wrong kind of help. Also, in mental health, believing that mental problems are purely biological or purely personal can affect how people feel about mental illness and whether they seek help. So how did these researchers find out what people believe? They basically created a survey. They asked 1006 adults in Switzerland to look at 25 different statements about the brain, learning, and mental health. Some of these statements were true, based on solid science, and others were the neuromyths. After people answered, the researchers counted how many statements they got right. They got a good mix of people, from young adults to older folks, and they specifically looked at whether being an educator made a difference. The survey had statements like listening to classical music increases reasoning ability, that is a classic neuromyth, by the way, and normal development of the human brain involves the birth and death of brain cells, which is a factual statement. People just had to say if each statement was correct or incorrect. Now, for the interesting part, what did they find overall? People did pretty well. On average, they got about 19 out of the 25 statements, right? That's pretty good. But here is the catch. They actually got the factual statements right more often than the neuromyths. On average, people correctly identified only about 56% of the neuromyth statements, compared to a much higher 84.7% for the factual statements. So, while we have a decent understanding of some brain facts, those tricky myths are still fooling a lot of us. And which myths were the most popular? The top 3 that people got wrong, meaning they believed them even though they're myths, were 1. Individuals learn better when they receive information in their preferred learning styles. Like the idea that some people are visual learners, some are auditory, and teaching needs to match that. This is a myth too. Some of us are left-brained and some are right-brained due to hemispheric dominance, and this helps explain differences in how we learn. Another big myth. And 3, listening to classical music increases reasoning ability, also known as the Mozart effect. This one was also believed by a lot of people. What else did they find? Age played a role. Younger adults, those aged 18 to 30, were actually better at spotting both neuromyths and factual statements than older adults. This is pretty interesting. It suggests that maybe newer generations are getting better brain education, or perhaps they're more exposed to critical thinking about science. However, even among the younger adults, the really popular myths, like learning styles and hemispheric dominance, were still believed by a significant number of people. Now, here is a really surprising finding. They compared educators, teachers, people working in schools with non-educators. You might think that people who work with children's development every day would be better at spotting these myths. But the study found no significant difference between educators and non-educators in how well they understood these statements or identified neuromyths. This is a critical point. It means that just being in the education field doesn't automatically protect you from believing these misconceptions. So, what does all this mean? The researchers suggest that this isn't just about people not knowing the facts. It is more about how we interpret and understand scientific information. These myths are often catchy and easy to grasp. They fit with our gut feelings about how things work. For example, the idea of left-brained versus right-brained. People is a neat, simple way to explain personality differences, even if it is not scientifically accurate. The study highlights that these myths might persist because they're intuitively appealing even when the actual science is more complex. The paper also points out something important. Even when a myth is believed by a smaller group, it can still have a big impact. People who believe these myths might spread them, and they can influence expectations about learning, parenting, and even mental health. It also mentions a phenomenon called the continued influence effect, where even after we're told something is false, the false belief can still linger and affect our thinking. This shows that misinformation is persistent and hard to shake. The fact that educators and non-educators perform similarly is a really important takeaway. It suggests that these neuromyths are part of a larger societal understanding or misunderstanding of the brain. And because educators are so central to how children learn, these myths can be passed down to students without even realizing it. This isn't about blaming teachers. It is about recognizing that educational systems might be unintentionally perpetuating these ideas. Of course, no study is perfect. The researchers mention a few things. First, because people knew they were taking a survey about brain knowledge, they might have been more careful and thoughtful than they would be in everyday life, which could mean they reported knowing more than they actually do. Second, figuring out who was an educator was based on their job descriptions, and there is always a small chance of misclassification. Third, this study looked at what people believe and how old they are, but it didn't dive into why they believe it. They didn't explore things like how much science education someone had or how they get their news. Finally, this was a snapshot in time, a cross-sectional study. It shows us what is happening now, but it can't definitively say if believing these myths causes certain things to happen in education or development. So, what is the big conclusion? Neuromyths are still a big deal. Even though we know more about the brain, these misconceptions are sticking around. They're not just for people who don't know science, they're for teachers too. This suggests that the problem isn't just about giving people more facts, but about helping them think critically about the information they receive. The researchers suggest that communication needs to change. Instead of just dumping more facts, we need to help people understand how science works, what we don't know yet, and why simple, catchy explanations might be wrong. They think that neuroscience should work with educators and the public to explain not just what we know, but how we know it and what the uncertainties are. This could involve making teacher training more focused on understanding brain development concepts rather than just memorizing facts. Ultimately, it's about building better scientific literacy, not just knowing facts, but knowing how to evaluate claims. And this goes beyond schools. Public discussions, adult education, and science communication all play a role by shifting from just sharing information to helping people interpret it wisely. We can hopefully chip away at these neuromyths and build a society with a more accurate understanding of the amazing human brain. What do you all think? Have you encountered these brain myths before? Let me know in the comments below. If you found this breakdown helpful, please give it a thumbs up and subscribe to RUBIN'S Mind Lab for more dives into the fascinating world of psychology and neuroscience. And as always, keep that curiosity alive.